Hi, let's see now arithmetic progression. We are still in chapter 1, but now we are in subtopic 3 and this is going to be arithmetic progression. Well, before I start actually telling you about arithmetic progression, I'm going to tell you the three types of progression that we have. The first one we have, it is the most simple one, it is the arithmetic progression. Arithmetic progression. This is the first type we have. Then we're going to have the geometric progression. Let's put it like this, because the third one is going to be like this. Okay, so this is going to be the geometric progression. And the last type, it is going to be, let's put scholar, the harmonic progression. Well, let's see each one of them. Of course, I'm just going to introduce to you those. And if you ask me, why am I going to introduce everybody if you're just going to study arithmetic progression right now? Because if I want you to understand this, you have to know that this, it's not this, and it's not this. Okay? In order for you to know what is black, I want to show you what is white, what is red, what is blue, and it's much more simple for you to understand this. Because if I don't show you this, chances are that sooner or later you might get a progression and it change a little bit and say, yeah, I thought it could be arithmetic progression. Because of this, I'm going to present to you everybody. I just feel more comfortable explaining to you the three of those. And just one thing, arithmetic progression, we just write AP. Then geometric progression, we just write GP. And harmonic progression, yes, you thought it right, it is HP. And let's see an example of each one. Well, arithmetic progression, it is the easiest one. That's one you're going to study. And it could be a sequence like this: 1, 5, 9. I'm just adding 4, okay? 13, 17, 21, and so on. And what I want you to notice, it is this: we're just adding 4. And this is the basic of arithmetic progression. We are just adding 4. Of course, we could subtract -1 or -2/3 or minus pi. It doesn't matter, okay? But whatever we are adding or subtracting, it must be a constant, okay? That is the most important thing. This thing must be a constant. It can be bigger or smaller. We're going to see in a few seconds, okay? The types, I'm not going to present to you those right now, but what I want you to understand, it is this. Let me take my ruler. What I want you to understand, it is precisely this. Well, let's take the chart, and this is what I want you to understand from here. This is, I'm going to chart. I am an engineer, and as you know, or if you don't, you're going to know now, engineers, everything for them are charts. So I'm going to do this on purpose, just for you to, later I'm going to explain to you. So here we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm not concerned about exactly, okay, how tall it is this, okay, the height of the x and y axis. Those are my terms, and those are the values. Okay, so the first term, the second, third, this is the fourth, fifth, and the sixth term. Well, this is going to be 1, this is going to be 5, this point is going to be 9, this point is going to be 13, this point is going to be 17, and this point is going to be 21. And what I want you to notice, it is this. Look, when we are presenting arithmetic progression, I'm not going to use this pen. This pen is not going, is going to block part of the beauty. I'm going to do like this. Okay? So, what I wanted to show you, it is exactly this. This is one point, another, 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 and another. When you just put them one next to the other one, this is my sixth term, the fifth, and so on, the fourth, the third, and so on. And this is the value. What I wanted to understand is this. They are going to form a straight line arithmetic progression, and more, and even more. Do you know what does it mean? This is alpha, right? The tangent of alpha, it is going to be exactly, in this case, this constant, okay? This 4. I'm going to write 4 in this case, right? Because I'm putting those. It's going to be 4. And this and this is exactly, okay, the AP, arithmetic progression, constant, okay? So the tangent, it is alpha, and why it is a straight line, a perfect line? Because we are not changing whatever it is being added. It is always 4. That is why we are always going to have the same tangent line, and that is why we are going to form a perfect line. Okay, now if we just put plus 4 plus 3, we are going to be changing what? Okay, the rate, okay, the angle of this line. This is what it means in charting. Okay, so this is a chart for arithmetic progression. Let's even make like this. Okay, good. Now let's go to geometric progression. Well, for that we have something a little bit different, and we are not going to add things, we are going to multiply things. Now let's imagine something like this, like 1, 4, 16. I'm always multiplying by 4, okay? Now 64 sorry, 256, 512, 1024, and 4000 something, and so on. Not going to continue. And the geometric progression, we are multiplying by 4. So the factor now, it is a multiplication by 4. You see? This is what it is to be a geometric. Of course, we're going to grow much faster, because here we're just adding 4. We started at the same initial value, 1, but just adding 4, first, second, third, fourth, fifth. In the fifth term we get 17. Now first, second, third, fourth. In the fifth term here we got 256, much bigger than this. So geometric progression, it grows very fast. And that is why we say it is exponential growth. And if we would chart the geometric progression, we would get something like this. Again, those are my values, and those are my terms. Like first term, second term, third term, fourth term, 1, 2, 3, 4, 5. I'm going to put fifth, but I'm not going to be able to plot that. And I'm going to first, I'm going to use all the same pattern. This is an exponential growth, okay? This is an exponential growth. Oh, I just forgot. The equation for this line in here, it would be like this. Y equals, you usually say y equals ax plus b, right? And let's write a times x plus b, okay? The a, it would be our 4, okay, in this case. This is b, okay? Why? Because when a is 0, okay, that's where we find the b. I mean, not a be 0. When x, okay, make x equal 0, like this, okay? If x equals 0, we're going to 0 this term in here, and y equals b. So for x equals 0, this is b. The b is where we just find in here. In this case, it is a positive value. I'm not saying it is positive because I didn't took the cautious to draw everything perfect, but you got the picture. This is b, and this is tangent. It is 4. Now, this is an exponential, and the exponential curve, it's like this. Y equals exponential, okay, of any number times x. This is going to be the kind, okay, and it would be something like this. This is our first term, our second, third, fourth, fifth, and so on. And we would have our first, it is 1, our second, this would be 4, so this would be 16, this would be 64, 256, and the other one would be right there, 1024. So this is geometric progression. Can you see? It goes much faster. It grows much, the speed is much faster, because that's how we say is an exponential. And what about harmonic? Harmonic, in my opinion, it's very interesting, because harmonic, it relates to arithmetic progression. In what sense? Well, let's first present, okay, their harmonic progression. It will be something like this. I'm going to write 2 or maybe 1. Let's just write just 1 here. Like I'm going to write 2. I'm going to explain later why. First, let's make just like 1, then maybe 1/5, then 1/10, 1/15, 1/20, 1/25, and so on. It does have to be 1 in here, okay? We could, instead of 1, it could be pi over 5, pi over 10, pi over 15. Usually people write 1, but that's why they write 1 because it's much easier to explain what I'm going to tell in the next seconds. But please don't frame into your mind that it must be 1, okay? It could be any constant in here, like pi or etc. And the harmonic progression, I'm going to write the definition is in here. It is when the reciprocal terms are in an arithmetic progression. Can you see? Invert them, just invert them. 1, 5, 10, 15, 20, 25. Can you see? When we just invert them, we must get an arithmetic progression. And something interesting about the harmonic progression is that it goes all the way to 0. At infinity, it is going to find the 0. Because we are just growing, growing, and growing. Again, this is the terms, and those are my values. My values like this, 1, 1/5, and so on. And now, what is going on in here? Now we're going to get something like this. It is going to tend to touch 0. It is never going to touch the 0, but it's going to be very close to 0 at infinity. Okay, in here. And again, I'm going to write, this is going to be my first term, my second, my third, my fourth, fifth, and so on. This would be number 1. This is 1/5. Oh, it should be red, right? 1/10, 1/15, 1/20, 1/25. You see, if we are growing, let's analyze here. As we grow the denominator, let's put in here something. I always like to make a recap of math. When we have A equals B over C, as we increase the denominator, we are going to decrease the general fraction, okay, the overall fraction. If we increase B, we increase A. If we increase C, we decrease A, okay, because we are dividing by something bigger, and therefore this one is going to reduce, okay, just like this. Let's divide one popsicle into 2 kids. Each kid gets half of the popsicle. Now, instead of dividing the popsicle for 2 kids, let's divide by 10 kids. Well, no wonder that each kid is going to get a very tiny portion of the popsicle. So the higher we divide, the less the overall fraction goes to. Okay. So if you are increasing the denominator, obviously each term it is reducing to a point that it is going to 0 at infinity. So this is what harmonic progression it is. And I just wrote this because it's very important that you frame into your mind that arithmetic progression, we do have to add a constant, okay? Could be +5, +3, -3, -17.25, doesn't matter. Minus pi divided by e. E, it is also a number, right? Okay, it doesn't matter as long as it must be a constant. Whatever crazy number you find in here, this very same crazy number must be added or subtracted in here. Okay, so the ratio is always the same, because if we just change what is being added, we are going to change the tangent. We are going to change the direction of this line, and we are not anymore into arithmetic progression. Okay, well, we could also make like this arithmetic progression. Let's just write one very easy in here. We could make like half, then let's just add 1, right? It is 3 halves, then 5 halves, then 7 halves, and so on. Okay, this would be also, this is just +1, right? How do I know? Well, this is half, this is 1/2, just adding 1. We're always adding 1, always adding 1, okay? It doesn't matter, but okay, the ratio, it is always the same. It doesn't have to be an integer, it could be a fraction, a decimal, anything, okay? As long as you just keep the same constants.